Hello everyone, today we will start set theory, and most probably we will complete it today. See, what are sets? Sets are well defined set of objects. So if you define something in a proper manner and it should arrange in a with some rules, then it will be called as a sets. Now list of sets, see, we already know from class 9-10 logic, but still we have to revise for our class 11 mathematics chapter. So see, any set of natural numbers, we know 1, 2, 3, 4, etc. And natural number starts from 1, that means 1, 2 up to infinity. So these are set of natural numbers. So natural number starts from 1. Now set of integers. So integers, it can be negative integers, -2, -4, 0, 1. These all are set of integers. If a set of positive integers, see, integer can be denoted as z and can be denoted as capital I also. Some book follow capital I. So set of integers, these are set of integers. Set of positive integers, we have to take from 0. Set of rational numbers, that is in the form p by q. So these numbers are also your set of rational numbers, right? Because 2 can be written as 2 by 1, 3 can be written as 3 by 1, that is, it is in the form p by q. So q is the set of rational numbers. Q plus set of positive rational numbers. R is denoted for real numbers, that is, everything will come into real numbers, negative, positive, fractional value, rational value, all the values will come. √2, √3, pi, all the values will come into real numbers. Positive real numbers for only positive numbers, and C denotes set of complex numbers. Now see, we can describe set in two manners, or we can represent set in two manners. One is roster form and another is set builder form. In roster form, in curly braces, we just simply mention the datas. That is, if we want to mention set of even natural numbers, that means only even numbers will come, 2, 4, 6, 8, 10, all those numbers will come. So this is a representation of a roster form. It's very easy. Now set builder form is for definition. You have to write the definition with some equation. So set of even natural numbers, this thing can be represented as see, x such that, this is such that, x such that x is a natural number. We have defined that x is a natural number, and what is the definition? Definition is x equals to 2n, where n is natural number. Where n is natural number, so x can be represented as x equals to 2n. What is x? X is a natural number. So that is the definition. If you put n equals to 1, you will get 2. If you put n equals to 2, you will get 4. So this thing and this thing are same. So in conclusion, roster form is simply within the curly braces we will write the datas only, and in set builder form we write the definition, that is in this form. Now see, let us see one question. 1 by 2, 2 by 3, 3 by 4, 4 by 5. This thing is in roster form, and it should the question is you have to write it down in set builder form. So set builder form, that means you have to write it in definition. So let us say x such that x equals to n by n plus 1, where n is natural number and n is less than equals to 9. So let's put, if n is equals to 1, then it should be 1 by 1 plus 1, that is 1 by 2. N equals to 2, n equals to 3 up to this n equals to 9. If n is 9, so it should be 9 by 10. So this is the set builder form. So it is extremely important. Now types of set. First of all, it is our empty set. That means there should not be any element. If there is empty, it is completely empty, null. It is nothing. There is nothing. But if you have a phi set, if you have phi within the curly braces, in that case you have one element there. Phi is itself a one element. So it is not a null set. Null or empty set means there should be nothing. There should be no element. So this is correct, this is wrong. And if you define this, this is a singleton set where phi is a null set. Now singleton means only one element should be there, singleton. Now see empty set definition in set builder form. X belongs to real number, x square equals to minus 2. So x square minus 2, but we know that here minus 2 in square root you cannot have minus. So we will have complex root here, right? Minus 2y plus 2y. So that is root under minus 1 is represented as I. So if you define this, x plus minus root under minus 2. Root minus 1 is represented as I. So this should be plus minus I root 2. This should be a plus minus I root 2. So one root is I root 2 and another root is minus I root 2. So it is in the complex representation. So it will come in the complex set. But see, what is the definition? X should be real number. Here we got complex number. So after solving this, what we will get? We will get nothing. That means we will get only 5. But if you put 5 within curly braces, that should be an element. Remember this, okay? This is extremely important. Now finite set, if you are listing something, let us say these are finite set. These are finite set, right? Because you can count. Whatever you can count, it should come within finite set. That means one which is counted or one which is labeled, that is denoted by n, small n. Now cardinal number or order. Cardinal number means order. So cardinal number or order of a set, let us say capital A is a set. So cardinal number or order of a set is represented by n of A. What is n? N is a finite set. Now what is infinite set? Which cannot be counted or which don't have any end. That is infinite set. Equivalent set, let us say we have two sets, A and B, and we are finding out the orders. See, if n of A equals to n of B, that means orders are same or cardinal numbers are same. That means number of elements are same. They should not be equal. They may be equal or they may not be equal, but their order should be same. Let us say we have something, one set 1 2 3 and another set as 2 4 5. See, here we have 3 elements, here we have 3 elements. So n of A equals to n of B. That means number of elements are same. Okay. So these are equivalent set. Now equal set. What are equal set? If number of elements are same in the two sets, number of elements should be same, and obviously order should be same, because if you have 3 elements here, if you have 4 elements here, there should not be any chance that every element should be same. So if you have one set as A 1 2 5 6 and in the B, C we have the same elements 1 2 5 6, so same element. That's why these two sets are equal sets. Always remember, in the set order is not important. See, here in the A set we have written down it as 1 2 5 6 and the B set we have written down it 5 6 2 1, the reverse order. So order is not important in sets and repetition is allowed in set. So let us see what is subset. See, subset, that means we have a bigger set and we can take one element, we can take 2 to 3 elements, we can take 4 to 5 elements. So if A is a subset of B, see, subset is represented by this symbol, it is read as A is a subset of B or A is contained in B, or you can say inversely that B is a superset. If A is a subset of B, then we can say that B is a superset of A, and superset is represented by this U, something written like this. If A is not a subset, then we have to cross this subset. This means that A is not a subset of B, or we can say that elements of A are not in B. You have to remember some points. Every set is a subset of itself. That means if we have a set 1 2 3, then we can say that A is a subset of A. That means 1 2 3 itself is a subset. This is the biggest set of 1 2 3, but 1 2 3 itself is the subset of A. What are the rest of the subsets? We can say 1 is a subset, 2 is a subset, 3 is a subset, 1 2 is a subset, 2 3 is a subset, and 1 3 is a subset. So we have total of 1, 2, 3, 4, 5, 6 subset, and another is 5 and another is 1, 2, 3. Count, you will get 8 subsets. So for 3 elements we are getting 8 subsets. Remember, 5 is a subset of every set. If you don't have anything common, then you will have 5 common in the subset. And see this 1, 2, 3. We have written 1, 2, 3 as a subset. So that means we can conclude that every set is a subset of itself, because 1, 2, 3 we have taken here as a subset. So A is a subset of itself. Now empty set is a subset of every set. So 5 contained in A. 5 contained in every set of A. Total number of subset is 2 to the power n. See, I have already given you an example. If we have 3 elements, then we will have 2 to the power n subsets. So 2 to the power 3 is 8, and I have written down all the 8 subsets. So this is extremely important. Now let us see what are intervals of subset. If we want to denote something x, A is greater than x is greater than A or less than equals to B, less than greater than equals to A or less than equals to B, this thing is represented in the closed interval. This is called closed. Third bracket is for closed interval. How to represent in number line? See, from plus infinity to minus infinity we have two numbers A and B which are closed. Closed means this dotted circle. This dotted circle. Open interval. First bracket represented as open interval, and in equation format you can say x is greater than A or x is less than B. This is less than equals to is closed. Only less than or only greater than is open interval A to B. How to represent in number line? That is bubble, in the form of bubble. Empty circle. This is closed circle, this is empty circle. So empty circle is represented in the number line for open interval, or you can say for this sign. And semi-open or semi-interval, let us say, we can have this example as this thing, that is x is greater than A, strictly greater than A, and less than equals to B. This thing is represented as A is open interval, that means strictly, this is known as strictly greater than A, and this is less than equals to B, because B is in the right hand side, so x should be less than equals to B. So this thing you can write down this in this format: open interval A, closed interval B. And in the number line, open sign, that is empty circle is for A, that means and B is the closed circle, that means your range is from A to B, open interval A to closed interval B. And if you note this as this thing, that is x is greater than or equals to A but strictly less than B, so open interval is for B side, so B side will be bubbled and A side will be dark circle. So your answer should be between A to B, but B should not contain. This means B is not contained in the set. This open interval means, or you can say strictly less than. This is strictly less than or open interval. There are various names. This is strictly less than. This is less than. That means this A and B elements are contained in the set. In this, B element is not contained in the set. In this, A element is not contained in the set. Solution should be between A to B, but A is not contained and B is contained, because here we have dark circle. Now universal set, where every elements come, is known as universal set. Let us say we have a set A 1, 2, 3, we have a set B 2, 4, 5, 6, we have a set C 1, 3, 5, 7. So what would be the universal set of ABC? That means every element should come, that is 1, 2, 3, 4, 5, 6, 7. Count, 1, 2, 3 is here, 2, 4, 5, 6 is here, 1, 3, 5, 7 is here. That means U is your universal set. That means every element of set ABC is contained in U. That's why U is known as universal set. Universal set is represented by U. Or in some book they follow zeta. In some book they follow zeta, we will follow U. Power set. What is power set? The subset of collection of all the subsets is known as power set. As number of subsets is 2 to the power n, as we are collecting all those subsets, that means our power sets, the number of elements in the power set should be 2 to the power. Let us see one example. Let we have a set A which have 3 elements 1, 2, 3. What are the subsets? We know that phi is a subset, then only 1, only 2, only 3, 1, 2, 1, 3, 2, 3 and 1, 2, 3. Count, we will have 8 elements. That means 8 subsets. So number of subsets, see, subset. These subsets written in curly braces is your power set. That means collection of all the subsets are known as power sets. That means we have here 8 subsets. That means our power set contains 8 elements. Now let us see what are Venn diagrams. Venn diagram is represented in a square box and sets are represented in the circles. Let us say we have 2 sets A and B, and this square box is your universal set. That means all the elements will lie in this square box. So how to find out union of sets by Venn diagram? See, union A union B. The meaning of A union B, it is extremely important for probability concept. In the probability we will extremely maximum we will use this union set, intersection of sets, disjoint sets. This will repeat in that lecture. So what is A union B? A union B means either A elements will come or B elements will come or both of them come. So this is extremely important, either A or B or both A and B. So see, this is our A set, this is our B set. So either A elements or B elements or both of them. So this is your A union B. Intersection, this is A intersection B. This is simple, that means both of A and B will come. So A elements, this is the set of all A elements. That means this portion, in this portion A elements will lie. This is the set of all the B elements. So in this portion B elements will be equal to A elements. So that means this middle portion is your A intersection B. That is common to both A and B, known as intersection. Disjoint, there will be no common elements between A and B. So disjoint set is your phi. If we do A intersection B, we will get null elements phi. Difference of two sets. If you want to find out A minus B, that means elements, set of elements of A which do not belong to B. Set of elements of A which do not belong to B. This is represented as A minus B. And set of elements of A, this is the whole set of A, and this portion, these elements are only lie in A, not in B. This is known as A minus B. And set of elements which lie only in B, not in A, this is represented as B minus A. And both of them, this is A minus B, this is B minus A, and this is A minus B. This whole thing is represented as A del B, and this is known as symmetric difference. That is A minus B, this is your A minus B, this is your B minus A, and you are taking intersection. What you will get? Nothing. Complement of a set. Complement is represented by, this is the set A elements, all the elements of say will lie within the circle. If we subtract A, if we omit the elements of A, so we will get the external elements. So this is represented as A bar or A complement, AC or A bar or A bar, A prime or A bar, all these are complement of set. And A complement is, you can write it as 1 minus A, or you can say U minus A. That is, from universal sets you are omitting the elements of A. That is difference, right? Difference of sets. From universal sets you are omitting the elements of A. That is your complement, because external, this all the elements are A complement. So A complement can be represented as this. Okay, U minus A. Now De Morgan's law, this is extremely important. Now A union B whole bar is your, this union will convert it to intersection and then do individual bar. this intersection, if you have A intersection B whole bar, then this intersection will convert it to union and then individual bar. Now let us see in Venn diagram. Let us see in Venn diagram. Let us say we have A and B. So what will be A union B? A union B means this whole thing. This whole thing is your A union B. Now A union B complement. That means we are omitting these elements and we are taking this element. That means our required area is external side. Now let us see. So in this diagram, this is the diagram for this. And what will be the diagram for this? Diagram for this will be, this is A set, this is B, this is universal set. Now A complement. A complement means we are omitting the A elements from universal set. That means whole this thing, whole this B will also come, whole this thing. Okay. Now what will be the B complement? B complement will be excepting B. This is omitted, so that means this element will come, this element will come except this. So in the first case we have this thing omitted out, and in the second case we have this thing omitted out. So if you do intersection, you will get only external side only. If you do intersection, you will get external side. So these two diagrams are equivalent. Okay. Now let us see Venn diagram for this thing. So we have two sets A and B. Now what is the intersection? Intersection is this, and you are complementing intersection. That means except intersection you will have all the elements. That means this is omitted out and we will have this, except the middle portion we will have all the elements. Now let us see this diagram. What will be the diagram for this? This is A set, this is B set, A, B, this is union. Now what will be A prime? A complement means except A, all the elements will come. That means this whole element. Now what is B prime? B prime is except B, we will have all the elements. So in the first case we have these elements omitted out. In the second case we have these elements omitted out. So if you take intersection, what you will get? If you take union, what you will get? The external. That means this is the whole portion. Except this is A intersection B, except this whole thing will come. This, and here except the middle portion, whole thing will come. So those two diagrams are equivalent. Now let us see 1 to 2 examples. So let us see some formulas which we will use in set theory. N of A union B is N of A plus N of B minus the formula we will use in this set theory, that is N of A union B equals to N of A plus N of B minus N of A intersection B. So let us see in pictorial diagram. We have two sets A and B. So what is the meaning of N of A? N of A means this whole thing. This whole thing is N of A plus N of B. Plus N of B means this thing we are adding. If you kindly observe that when we have taken N of A, then we have taken this part already, and addition to that when we have taken N of B, then again we are taking this interval, this part. So we have taken this part twice. So N of A union B should be N of A plus N of B. As we have taken this middle part as twice, then we have to subtract 1 N of A intersection B. This is your N of A intersection B. So we have to subtract 1 N of A intersection B from this. So this is the proof. Now see, N of A union B is N of A plus N of B. If when this will happen? This will happen when A and B are disjoint non-void set. See, if A and B are non-disjoint set, that is, this is A, this is B, these are disjoint set, right? So in this portion we don't have any N of A intersection B part. So in this part we have only, if you want to denote N of A union B, that means N of A plus N of B, that's all. N of A minus B can be represented as N of A minus N of A intersection B. Let's see this, N of A minus B. So we have already learned that N of A minus B is this part. N of A means this whole part. Subtract this part, subtract this part. So we will get this part. So that means N of A minus B can be represented as N of A, this N of A minus n of A intersection B. So you will get this part only, that is n of A minus B. That is the formula. And n of A intersection, n of A union B union C, n of A union B union C can be let us see this picture here. N of A union B union C. So we have three sets now, A, B and C. So let us say this is A, this is B, this is C. So n of A, when we are taking n of A, that means we are taking this whole part. N of B means this part. See, we have taken this part twice. Okay, so that means we have to subtract n of A intersection B, which is this, plus n of C. So when we have taken this part, we have taken this part and this part twice. So that's why n of B intersection C, B intersection C, that means this part is subtracted once. N of A intersection C, this part subtracted once, and this part we haven't added. So this is n of A intersection B intersection C. That means common to three sets is this part. This part is only your n of A intersection B. N of A intersection B is only this part. N of A intersection C is this part. N of B intersection C is this part. This part is n of A intersection B intersection C. Actually, n of A intersection B is this whole part. But when we have subtracted n of A intersection B, that means we have omitted this part and this part also. When we have subtracted n of B intersection C, that is this whole part, we have subtracted this part and this part. And when we have subtracted n of A intersection C, that means we have subtracted this part. So we have not taken this part, common part. That's why we have added n of A intersection B intersection C. So this is the formula, and this is extremely important. Now let us see this. In a class of 35 students, so in a class of 35 students, 17 have taken mathematics, 10 have taken mathematics but not economics. Find the number of students who have taken both mathematics and economics, and the number of students who have taken economics but not mathematics. If it is given that each student has taken either mathematics or economics or both, that means let us say A is the set of number of students who have taken mathematics, B is the number of set who have taken economics. Here we have only two variables, mathematics and economics. If we have three variables, we will get C. So in the last this formula, we will use this formula. So see, it is given that in a class of 35 students, that means the mathematics students and economics students, total of 35 students. So total of 35 students means, that means n of A intersection B is given, A union B is given, total of mathematics and economics, n of A union B is given as 35. 17 have taken mathematics. So we have assumed that A is the set of mathematics. So n of A is given, 17 students have taken mathematics. 10 have taken mathematics but not economics. A subtracted from B. 10 have taken mathematics, 10 have taken mathematics but not economics. So n of A minus B is given as 10. Find the number of students who have taken both mathematics and economics. Both mathematics and economics, that means you have to find A intersection B. So your first target is to find n of A intersection B. So what is the intersection? Intersection of common part. Common region means both mathematics and economics. And so let us see it in diagram, so that the whole thing will be clear. Now let us say this is your A set, that means this is mathematics. Let us say this is your A set, and this is your economics, that means we have taken it as B set. Now see, it is given that total of 35 students, that means this whole set, that means economics and mathematics, total is given as 35, it is clear. 17 students have taken mathematics only, that means this whole thing, is your mathematics, right? This whole thing is your mathematics. So n of A is 17 given, that means this is your mathematics. Now 10 have taken mathematics but not economics. 10 have taken mathematics but not economics. That means what is the region? This is the region, right? This whole thing is for mathematics. That means here economics term will also come. So if it is given that 10 have taken mathematics but not economics, so that means this term only, this is the only mathematics, this is the only economics, and this part is for economics and mathematics both. You have to find this region. Okay. So see, in the last we have formulated that n of a minus b can be represented as n of a minus n of a intersection b. We will use this formula because we know NA, we know n of a minus b. We will put it here and we will find n of a intersection d, that is 7. Now we will use this formula, that is first formula, n of a union b is n of a plus n of b minus n of a intersection d. N of a intersection d we have just calculated out. N of a is given, n of a union b we know, from this we will get n of b. That means only number of students of economics. The number of students of economics means here some mathematics students will also come. Number of students of economics, that means there are some students who have taken economics and mathematics also. So n of b is 25. Now let us see, but not economics. If it is given that each student has taken either mathematics or economics or both, and the number of students who have taken economics but not mathematics, we have to find this out. So we have to find economics, only economics but not mathematics, that means this part. We have to find this part, that means this part is n of b minus a. We know this is the region where only economics is there but not mathematics. So n of b minus a we have to find. Now again we will use this formula, n of a minus b or b minus a equals to n of b minus n of a intersection b. So n of b can be written as n of b minus a plus n of a intersection. N of b intersection a or n of a intersection b is the same term. So n of b is 25, we have just calculated out. N of b is 25. N of b minus a is given, that is n of a minus is given, n of b minus is not given. N of a intersection b we have calculated out, that is 7. Now subtract, you will get n of b minus a, which is 18. That means 18 students have taken economics but not mathematics. But still, if you want to find it out with this, from this diagram, you can say that there are total of 35 students. This is the region of 35 students. There are total of 35 students. 10 have taken mathematics but not economics. That means we have 10 here. 10 have taken mathematics but not economics. That means only this region. Find the number of students who have taken both mathematics and economics, and the number of students who have taken economics but not mathematics. That means we have to find out this region and this region, and this can be we can find it out by the formula we have used here. That is the pictorial representation. So I think that's it for set theory. Practice more this type of problem from your textbook. I hope you are liking it. Please like, share and subscribe. All the best.